Let's look at linear inequalities in one variable. An inequality means that it's not equal. There are 4 different inequalities that you could use, and then there is the unequal. So the inequalities that we have are less than, which looks like this. We have greater than. We have less than or equal to. And we have greater than or equal to. So here's our first question. So we have x is less than 5. If you're having trouble remembering which one is less than and which one is greater than, think about the inequality this way. If you squint and turn your head sideways, kind of looks like an L if you get a little sloppy. But that one's less than, so maybe that will help you remember. So we have x is less than 5. If we notate on our number line, 5 being right here, that means that we need all the values that are less than 5. So 0 would be on this side, 10 would be on this side as we count on our number line. So all the values less than 5 would be all the values from 5 and below. We can't use 5, so we're going to use a parenthesis, but then we can use all the values less than 5. So it would look like this. In addition to graphing this on the number line, we can write this in interval notation. Interval notation means that you write all of the values that can be used as a solution to this inequality. So in this case, if this arrow continued to the left, it would be pointing towards negative infinity. So our interval notation would mean we could start at negative infinity. We can never touch negative infinity, so it would have a parenthesis. And we can go all the way to 5 without touching 5. So a parenthesis on the other end as well. Let's look at another one. So we have x is greater than negative 2. So if we draw our number line, we can put negative 2 right here. Now this is negative 2, so if we move to the right, getting larger, we would have 0. And move to the left, getting smaller, then we would have numbers like negative 3, negative 4, so on and so forth. So this is saying x needs to be greater than negative 2. So there's no or equal to underneath, so that means that we have our parenthesis again. We cannot use negative 2, but we can get as close to it as possible. And then anything larger. To write this in interval notation, while reading it from left to right, so reading it here, the first thing we'll be able to use is as close to negative 2 as we can get without actually touching, so a parenthesis, and then all the way up to infinity. We can never touch infinity, so we'll close it with a parenthesis. Let's try again. So next we have x is less than or equal to 3. So if we draw our number line, we'll just put 3 right here. So moving larger would be 4, moving smaller would be 2 as we go down. So we need x to be less than or equal to 3. Well, now it's or equal to, so that means that we can include 3. So we will use a bracket. So anything less than 3 all the way up to 3. Looking at our interval notation, coming from the left, that would look like negative infinity. And on the right, we have a hard stop at 3, so we'll use our bracket. Let's look again. We have x is greater than or equal to 0. So on our number line, 0 would be here. Moving to the right, getting larger, we'd have 1, negative 1 to the left. So it needs to be greater than or equal to 0. So we have our bracket, because we're able to use 0, and anything greater than. So looking at our interval notation, reading from the left, we're able to use 0, so we have our hard bracket, and to infinity. We can never touch infinity, so we'll use our parenthesis for infinity. Sometimes you have multiple inequalities represented in the same question. So here we have negative 2 is less than x is less than or equal to 3. So let's draw all this on our number line. So here's my number line. So x is somewhere in the middle. Negative 2 is here. 3 is here. So this is saying negative 2 is less than x. So that means that x has to be greater than negative 2. But at the same time, x has to be less than or equal to 3. So we'll have a parenthesis at negative 2 because I cannot touch negative 2. But we can have a bracket at 3 because I can touch 3. So all of the values represented here are such that x is greater than -2 and x is less than or equal to 3. So looking at our interval notation, we have a parenthesis for -2 because we can't touch it. But at 3, we'll have a bracket for a hard stop. Let's solve some equations using the same idea. Let's solve some inequalities using the same idea. So here we have, for question 1, x is less than or equal to 4. Nothing to solve here. We can just graph this one. So here's our 4. Here's our hard bracket. Anything less like this, our interval notation is -infinity up to 4. Number 2, x minus 3 is greater than or equal to 7. So just like when we were solving our equations and we looked at undoing our order of operations, we're going to follow the exact same steps for our inequalities. So here we have subtraction of 3. So in order to get x by itself, we would add 3 to both sides. And that leaves us with x is greater than or equal to 10. So if we draw our number line, put 10 right here in the middle, so 11 would be this way, 9 would be this way. We need x to be greater than or equal to 10. It has the or equal, so we can use our bracket, and greater than goes this way. So using our interval notation, we have our bracket for 10 all the way to infinity, and we can never touch infinity, so there's our parenthesis. Look at number 3. Number 3, we have -5x is greater than 25. Now there's a special case here. Whenever you multiply or divide by a negative, so in this one we need to divide by -5 to get the x by itself. -5 divided by -5 is +1. But whenever you multiply or divide by a negative, you have to reverse the inequality. So see how we had greater than, and now we have less than. 25 divided by -5 is -5. And if we go and graph it, it's only when the number you're dividing by, see here how we're dividing by -5? It's only when the number you're dividing by, or if you had to multiply on both sides, if that number is negative, that's when you switch your sign. So here's our -5. A value smaller would be -6. Larger would be -4. And it is saying that it needs to be less than. So a parenthesis, I cannot use that -5. And everything to the left. So our interval notation would be -infinity up to -5. Let's try again. Number 4. 4x plus 1 is less than or equal to -31. So solve it down just like you normally would if this were an equation. So we have the plus 1, so we need to subtract 1 from both sides. So that's going to give us 4x is less than or equal to -32. Divide both sides by the 4, which is going to give us x is less than or equal to -8. Now in this step, we divided by 4, and we divided by 4. That 4 is not negative. The -32 is negative, but the 4 is not, which is why we did not reverse our inequality sign. It's only if the number you're multiplying or dividing by, like I have shown here in that green 4, is negative. In this case, it's not, which is why our inequality did not change. So then, we can graph this. So -8 would be right here. We need less than or equal to -8, so we can use our bracket. And our interval notation. There we go. Let's try number 5. So this one, we need to simplify from the center here. So whatever we do to the center, we have to do to all of the parts. So I need to get rid of this plus 2, which means I'll subtract 2, which means I have to subtract 2 from every single piece. Once we do that, we have negative 16 minus 2 is negative 18, and then everything carries down. Negative 10 minus 2 is negative 12. And then I need to divide by 3, because 3 divided by 3 cancels to 1. So I need to divide everything by 3. Negative 18 divided by 3 is negative 6. We have the x. Negative 12 divided by 3 is negative 4. So let's position this on our number line. Notice we did not change the inequality symbols because we are not dividing by a negative value. So this is saying negative 6 is less than x, and x is less than negative 4. So we need a parenthesis at both, and our interval notation would look like negative 6, negative 4, with parentheses at both. Let's keep going. Number 6. So I want to get rid of that negative 5. Remember when we were solving equations and we had the negative, or the fraction, we put the numerator in parentheses? We're going to do the same thing here. I want to get rid of that negative 5. So I'm going to multiply both sides by negative 5. But what happens when we multiply or divide by a negative? We have to switch that inequality. So we have 3x minus 6. And 6 times negative 5 is negative 30. Then, if we continue down, we need to add our 6 to both sides. So we'll be left with 3x is greater than negative 30 plus 6 is negative 24. Then we need to divide both sides by 3. So that will leave us with x is greater than negative 8. Putting that on our number line, here's negative 8. There's no or equal, so I can use my parenthesis, and then it goes to the right. In interval notation, that looks like negative 8, comma, infinity. Let's try again. There we go. So first step, just like if we were looking at an equation, is to work through our distribution. So when we do that, we get 28 minus 7x plus 5x is less than 2 times 16 is 32 minus 2x. And then if we simplify it down, negative 7x plus 5x is negative 2x. And then if we keep going, we're going to notice a little problem here. If I were to add 2x to both sides, this one will cancel, and so will this one. But look what happens. We get 28 is less than 32. Is that a true statement? It is a true statement. So this means anything that you would want to choose for your x will work, and it will make this side less than this side. So this one is all real numbers. Let's try again. All right, first step, let's do our distribution. And then we're left with x minus 3x. Now remember, you're distributing a negative 3 here. So minus 3 is less than or equal to 4x. You need to clean this up. X minus 3x is negative 2x. Minus 3 is less than or equal to 4x. We can add 2x to both sides. Yes, it's a negative here, and yes, we're adding it, but that does not change our inequality because we're not multiplying or dividing. So if we add 2x to get rid of the negative 2, and then we divide by 6, it turned out to be negative, but we are not dividing by a negative, so we do not change our sign. Sometimes people have trouble looking at it this way. This is saying negative 1/2 is less than or equal to x. If you reverse it around, this would be the same thing as saying x is greater than or equal to negative 1/2. Notice I did not just flip the inequality sign, I rewrote the expression like this. I rewrote the inequality. See how it's opening towards the x? See how it's still opening towards the x? If you have trouble reading it this way, you can change to write it this way, but make sure the inequality is still having the same value. So yes, here it was less and here it is greater, but it is signifying the x is greater, it is signifying the x is greater. So if we write this on our number line, here's negative 1/2, and we're saying x is greater than or equal to negative 1/2. So we can use our bracket. And in interval notation, we would have our bracket, negative 1/2, all the way to infinity. Let's try again. Again, we start with our distribution. And 5 times 1/5 x is just x. 5 times 2 is 10, is less than. 10 times 1/5 is 2, so 2x. 10 times 1 is 10. If we combine our like terms, so let's move our x over here. So we'll have 10 is less than x plus 10. And then subtract our 10. 0 is less than x. And there's nothing wrong with having a 0. That's a valid number, and in this case, it's part of our inequality. Now, just like the last one, if you have trouble reading it this way, you can rewrite it. See how the inequality is opening towards the x? It stays opening towards the x. So 0 is less than x is the same thing as saying x is greater than 0. And we write that on our number line. And with our interval notation, it'll look like that. Let's look at this in an application. So our question says, to pass Algebra 2 requires an average of at least 70 on 4 tests. A student has scores of 80, 62, and 73. What possible score on the 4th test would guarantee the student a passing score in the class? So to pass Algebra 2 requires an average of at least a 70. So that means that their grade needs to be greater than or equal to a 70. A student has scores of an 80, a 62, and a 73. So what would they need for that fourth test? And then remember, to find an average, you add them all up and divide by 4. So this is what we have for the students' scores so far. Now we need to solve it down to figure out what they need on that fourth test. So let's start by cleaning it up a little bit. 80 plus 62 plus 73 is 215. We need that to be greater than or equal to 70. So we can multiply both sides by 4 to get rid of that denominator, and that will give us x plus 215 is greater than or equal to 280. Subtracting 215 from both sides, we get x is greater than or equal to 65. That means that the student needs at least a 65 in order to get a passing grade of a 70 in their class.